Hello everyone, we are pleased to bring you together for this 30-minute webinar dedicated to enabling instance analytics on Amazon S3 and or Redshift. We will come back to some good practices for an efficient BI, implementing Indexima on AWS to succeed in instant analytics, and a use case dedicated to on-demand video corporation. To start this webinar, I'm pleased to introduce Florent Voignier, co-founder, president, and technical director of Indexima. Hello, Florent, the floor is yours.
Thank you, Laetitia. Hello, everyone. Thank you for joining us for this Indexima webinar about analytics in Amazon Cloud. To begin, I will introduce myself quickly. I am Florent Voignier, founder, CEO, and CTO of Indexima. Before creating Indexima, I was a consultant as a big data expert and architect. As I was working at MAPI, the major actor of French cartography, I created Indexima. I was there to design their BI big data platform, and very quickly I got performances issues connecting a BI tool such as Tableau on a big data cluster. To solve these problems, I designed a prototype which got very quickly into production at MAPI. We'll see in this webinar how to drastically increase the performance of your BI while reducing infrastructure costs. An important factor to consider for BI in the cloud is a choice of a storage system that must be independent of the compute. This allows for a better scalability and greater flexibility thanks to the elasticity of such an architecture. Another factor to consider is the engine for handling BI requests. It must be able to respond instantly to requests from analysts, especially if you are in a self-service BI context where it is not acceptable to wait several minutes for each click. We present a first architecture where the data is stored on S3. We can do a data lake of files on S3. The advantage of the data lake is that the data does not need to be structured in a predefined scheme in advance. This allows great flexibility to address multiple use cases. S3 also allows a very high scalability, several petabytes, while having a very moderate cost. The problem, however, is in reading performance. To query data on S3 with a distributed SQL engine such as Athena, Presto, Hive, or Impala, it may take several minutes for each query. In the context of self-service BI, it is quickly unacceptable for an analyst to wait several minutes with each click. This is where Indexima comes into play. Thanks to an innovative indexing technology that distributes multi-dimensional indexes in RAM, data can be directly requested on S3 with instantaneous performance. Indexima receives queries from analytical tools such as Tableau, Power BI, Excel, MicroStrategy, or ClickView, and responds in milliseconds regardless of the amount of data stored on S3. Here is another architecture where the data is stored in an Amazon Redshift data warehouse. The advantage of the data warehouse is to structure the data to be able to treat it more easily. However, there are performance issues when directly connecting an analytics tool to a data warehouse when data volumes are important. Indexima then accelerates the queries by placing itself between the BI and Redshift. This adds an indexing layer for instant response times. In addition to reducing response times by 1,000, Indexima also reduced costs by reducing the number of servers dedicated to the data warehouse. We will start an Indexima cluster in the AWS infrastructure. The easiest way is to use Amazon CloudFormation service to automate the deployment process. Once logged into the AWS console, we choose the CloudFormation service. To instantiate a new Indexima cluster, we click on Create Stack. It is then necessary to choose a JSON file, which is a CloudFormation template provided by Indexima. Any element of the Amazon infrastructure need to run the cluster will be automatically created by the script. So now I click on Next. And once you have chosen the CloudFormation template, we come to a page allowing you to simply specify the characteristics of the Indexima cluster. We give a name to the cluster. Then we have the AMI ID provided by Indexima. We can set where on AWS S3 are located the configuration file. Then we size the hard drive for the server. We just need a few amount of data because most of the data created by Indexima is stored on S3. Then we choose the elastic IP. It will be the entry point of the cluster. Then we choose an instance type. We need instance with enough RAM. So for example, I choose M4 2X large. And then we choose a key pair to be able to connect to the server. We choose a number of instances in the cluster. I choose 8 servers for this demo. Then we choose a spot price because we choose spot instance. The spot instance can get you a significant price reduction on EC2 servers. Then we choose a VPC and a subnet. And finally, we choose the S3 bucket, the F3 bucket, on which will be stored all the data created by Indexima. We click twice on Next. And then to instantiate the cluster, we click on Create. Our CloudFormation stack is being created. It can take several minutes to instance the cluster. So now we can go to the EC2 console by choosing the EC2 service to see the different server on the Indexima cluster. So I click on Instances, and I can see 8 servers that are running. So once the cluster is launched, you can go to the administration web interface. We have to log in with a username and password. We choose a project. We click on Data Spaces to get the list of tables available in this Indexima cluster. And for each table, we have the structure of the table with the different columns and their type. We can see the list of indexes and we can get the contents of the table. with all the columns. And by clicking on logs, we go to the monitor page. And the monitor page, which allows to follow the SQL query that are sent to Indexima. We have the response times for each request that will allow us to follow the performance of the Indexima engine. Now we will use Tableau software, which is a self-service BI tool, to create a dashboard by connecting directly to Indexima. So I have already prepared a Tableau data source that points to Indexima. So now I just need to enter my password. And I enter the password, sorry. So I select the number of records in the table. So the number of deliveries, because the data we are going to request comes from a parcel delivery company. 20 million parcels are delivered daily in the world, or 12 billion per year. Over a few years of history, we have more than 80 billion records. And as you see, in the table, I have 81 billion of rows in the table. So now I'm going to choose any dimension, for example, the date, to have the number of deliveries per year, and I can get it per month or per day. And each time I click in Tableau, it sends a new query, a new SQL query to Indexima. And as you see, the response time is just 10 milliseconds. So the query on a table of 80 billion rows takes just 10 milliseconds to respond. So now I can add any other dimension. For example, the user device, or I can change by the delivery mode, and it's instantly refresh. Each time I click on the dashboard, it sends a new query, and we have always response time in milliseconds, as you see in the monitor page. So now I'm going to create a new sheet to see, for example, the user devices that are used to send the packet. I choose the number of records as a measure, and I select another measure, the distance count of user device model. The distance count is an interesting query because it's a very heavy query. Usually with most SQL engine, distributed SQL engine, it can take several minutes, 10 minutes, 20 minutes to respond. And as you see, the distance count query on Indexima takes just 200 milliseconds. I can go deeper in the data to get a very high level of details. And it's always refreshed instantly. So now I'm going to create a dashboard that combines the two sheets together. So I select the third sheet that shows the number of deliveries per year. And I select the second sheet with the user devices. I connect the two sheets together. And then I can choose one user device. And instantly, the other chart is refreshed. And it sends a new query to Indexima with 16 milliseconds only. You can select another user device. We can even select a random, make a random selection of the time. It is instantly refreshed. And as you see, maybe it is not really connected. Yes, now it's connected. And as you see, the SQL query sent to Indexima is more complex because I create a random selection, but the time to respond is just 39 milliseconds. So now I'm going to create a third sheet with a map. For example, if I want to see the countries from which the packets are sent, it shows a map, and I can choose a number of records as color. And in the dashboard, I add the map. I connect the map to the other charts. And if I want to see all the deliveries from UK, I just click on the map, UK, and instantly the dashboard is refreshed. And the query sent to Indexima is just 8 milliseconds, as you see. So this example shows the use of Tableau with Indexima, but you can use any other analytics tool such as Microsoft Power BI, Excel, MicroStrategy, ClickView. And here's what it is using Power BI. So this is Power BI that points to the Indexima cluster on the same table of 80 billion rows. And we can see the queries sent by Power BI. The query seems to be more complex, sent by Power BI, but the response time is just 7 milliseconds. So for this demo, I used only one table, but we can also make joins between several tables and always have the same instant performance. For example, to model a star schema, which is very classical in BI. So, to summarize what we have seen, Indexima can drastically improve the performance of analytical tools while being very simple to implement. The Indexima Data Hub is secured with fine management of access rights at the table, column, and row level. Indexima is based on an innovative indexing technology called hyperindex. These hyperindexes are automatically created from user queries using machine learning algorithms. The system learns from users, and the more it is used, the more it is efficient. The Indexima Data Hub also enabled a significant reduction in infrastructure cost by reducing the number of servers. Finally, here is a use case of a French media that recently migrated its data to the Amazon cloud. Every day, 300 million on-demand video events are handled by Amazon Kinesis. These events in JSON format are then stored every minute in a data lake on S3. Indexima allows analysts through Tableau and Power BI to accurately track the consumption of their on-demand video service. All data from the data lake are available for analysis. Complex queries on the distinct count of users respond in less than 1 second in the different dashboards.
Thank you very much, Florent. The slides and the recording of this webinar will be available in 24 hours, and we will send them to you by email. Moreover, you find on our website, indexima.com, different resources such as datasheets, solution brief. Do not hesitate to contact us for any further information at contact@indexima.com. Have a great day, everyone, and see you soon.